Hi everyone, my name is Jiten. This is part 8 of our series Core Java series, and we'll be learning in this video that what is collections framework, iterable, list, set, queue, map, and when do we use it, and what is the requirement, and why do we need them. So let's get started. So this is the complete hierarchy we have. There are two parts in this video. First, we will understand about the iterable, then collections, and the subparts of collection. Then, other than this collection, we will be understanding the map. How do we use map and when do we use map, and the internal working of HashMap. Okay. So let's start with the iterable. Iterable is the supermost interface for collections. Iterable is an interface. Then collections is an interface which extends iterable, and under collections we have separate list, set, queue. These are the subparts. And why do we need them? Let's understand first one by one. So list. So what is list? So as you know, list is what? Is a set of data which is ordered and allows duplicate. So all these things what I have written here: dynamic array, fast, random, access, slow, insertion. So these are the properties of the ArrayList, LinkedList, and vector list. And based on those properties, we have to use this collection. So let's say I have to store the data where I want to be stored. I want the data to be stored in ordered manner. Ordered manner means like the first, when I insert first data, it should come first, then the second data, then third, like row wise. It should be ordered. When we insert the data, then only the data will be inserted on that position only. It should not be shuffled, right? And it allows duplicate. For example, we have a class, and in that class we take admission, like, and in class 10 we take admission of students to be studied. So in that case, let's say there are a student who comes first, that person, that student will get the roll number 1, then the roll number second, third, 4, 5, 6, 7, and we'll assign the roll number similarly. But in that case, do we have the name duplicate? Yes, we can have the duplicate names also. uh, with the name Rajan, we can have 2 students. With Jitendra, we can have 3. With Rahul, Rohit. So similarly, it allows in list data set, in list collection part, we store the data which is ordered, like first, then second, then third, fourth, and it will allow duplicate. And there are some parts of list where we have linked list, array list, and vector list. They have list has 3 part where their properties are different from the list. They will have something distinguishing. For example, in array list we have dynamic array. Dynamic array means we store the data and it will increase the size dynamically. Next thing, it is used to access the data, to get the data. So whenever we are doing some operation, we have to do some operation where we are fetching the data frequently. In that case, we will use array list, and it will be slow. When let's say we are fetching the data, but at the same time with array list only, I'm also saving some data, I'm inserting some data, so that insertion will be slow. We can do insertion and fetching both using array list, but the thing is, it will work very fast to fetch the data, but slowly to insert the data, right? Now let's talk about the linked list. Linked list is opposite of this, but it has the doubly linked list. That means in linked list you will have some node. What is node? You can see this on Google. I'll explain you. I'll give you some idea about this, because it will be out of the scope of this video. Doubly linked list, we call it doubly because it has linked node on the both side. Let's say I will give you this. So this is the box, this is the element, and let's do this. Okay, to we have to have the line only. Okay. Inside, inside. Okay, it does not allow inside, so let me take this one only. So you see, inside this there will be one element saved. Let's say 5 number is saved, and there will be a node here in this part and node in this part. Node is nothing but the address of the next element. If the next element is attached to it, it will be attached with this node, and the previous element will be attached with this node. And you can assume it something like a cart of a train. A cart of train is attached to both ends. They have hook on the both ends. Node will behave here like a hook of its cart, and it will attach the next node, next cart with this hook, which is node, and the previous node. So that's why it is doubly linked. It is linked to both sides, and it is fast to insert the data. But if you want to access the data, if you want to get the data, it will be slower. Okay, so that is that. Now let's talk about the vector. Vector is synchronized array list. It is the legacy. It is the very first part, you can say. In the beginning we used to use vector, but nowadays we do not use that much. It is synchronized array list. Synchronized means we have synchronized means one by one. For example, synchronized is synced with the number. Let's synchronized will be one step at a time. Like if anything happens, the insertion and fetching data is happening, it will do one action at a time. So that is synchronized array list. So if I give you example for synchronized, it would be like this. For example, if I'm going to write this line, I'm trying to write like this one: array list dynamic array first random access. So I'm writing first array list, then dynamic array first random access. This will be synchronized sync, and whenever we are doing this action, the dynamic array or any other action will not be performed. It will be step by step. So while processing it, the one resource can access it, otherwise any other actions cannot be done uh, at the same time, one action at the time. Okay, so this is all about collection part and list. In list we have three parts: array list, linked list, and vector. When do we use all them? Whenever we have to fetch the data, we will use array list. Whenever we have to do some manipulation, deletion, insertion, we have to do, we will use linked list. Now let's talk about set. Set is everything about duplicates. So whenever we do not want any duplicates in our data, then we will use the set data set. So in set we have HashSet, linked set, and TreeSet. Three of them have different properties. So let's understand the set first. So in set there would be no duplicate. So think of a situation where we do not want any duplicates. So in roll number, whenever we have any roll number or application number, we do not want any duplicate. So in that case, if we are assigning the roll number or application number, we do not want any duplicate. In that case, we'll use set. And in set also, if we want to use the set where we do not want order guarantee, for example, there is a key, we have to generate a key or random number we have to generate, and it should be unique, but it is not necessarily, it should not be necessarily, it should not be necessarily ordered. I mean, it can be, it can come first, it can come later. So there is no order guarantee. Order guarantee means order wise. Next, if we are using linked HashSet, wherever we say linked HashSet or linked HashMap or linked list, it will also be, it will also maintain insertion order. Linked is used when we have insertion order maintained. Whenever we are inserting any element in linked HashSet, linked HashMap, or linked list, it will maintain the order. So that's the unique part about this linked HashSet. Everything will be same. No duplicates will be allowed here also. Now let's talk about TreeSet. TreeSet will be sorted order. It will not have any duplicate also, but it will be sorted in natural sorting order. The data we save, it will be sorted automatically because we are using TreeSet, and TreeSet's behavior is that it will not accept any duplicates and it will have natural sorting order. Natural sorting order is increasing order. So let's say we have number 5, 4, 1, 3, then it will be making it 5, 3, 4, sorry, 1, 3, 4, 5, like increasing order it will do. Now let's talk about the queue. This is wrong here. Let me hide this. We have priority queue and DQ here. Priority queue is the queue where we have natural custom ordering, and DQ is array DQ. It is double-ended queue. It is a type of queue where it is double-ended queue where we can do some manipulations, right? So this is about queue. Now let's talk about the map. Map is nothing but a key value pair key value pair part data set where we have a situation where we need to store the data in key value pairs. So in key value pairs, what we do? Let's say in we have to register some students, and how do we register the students? So we have to give some number. We give roll number against the name. So that's the HashMap arrangement. So let me show you this because this is important. HashMap, we use HashMap a lot of times. Let's start the Eclipse first, and let's understand meanwhile Eclipse is starting. HashMap is what? It will store the value key value in key value pair, and there will be no order. It will not, the data will not be in order. The way it is inserted, it will be shuffled. It will not show the way it was inserted. Like, if you want to be managed the order insertion order to be maintained, then we will use linked HashMap as I have told you earlier. TreeMap sorted by key. It is what? It will give natural sorting order and it will be sorted by key. And hash table is what? Synchronized HashMap. It is a part of HashMap only, but it is synchronized. Okay. So this is HashMap. So let me, meanwhile Eclipse is opening, let me make you understand the HashMap internal working. HashMap internal working. So in HashMap, what happens whenever we have any key and value? Let's say I have roll number 1 and name is Jitendra. Okay. So in that case, it will create, HashMap will create one hash code via hashing techniques, hashing hash code, and based on that hash code, it will be given the position in the bucket. Okay, and initial size of this bucket is 16 in HashMap, and it is auto increment. And it may happen that sometime the hash code, the position in the bucket comes same for two elements. That part is called collision. So to solve this collision, we have linked list attached to this position, linked list. So we'll save the data in linked list. We will save the data in linked list, or later after Java 8 we have red black tree. These are the implementation you need to just understand in terms of giving answers to the interviewer. So what is happening here? Eclipse is not working. Let's start it again. Eclipse. Okay, so we have any hash map we have created. In hash map we have key and value. In that key and value it will pick up the key and it will do the hashing. The process is hashing, and while doing the hashing it will create, like in hashing it will create a hash code which is a numeric value. Based on that hash code, the position, the indexed position will be given in the bucket. What is bucket? Bucket is nothing but like these boxes, like these boxes you can also say like 1 2 3 4 5, the background boxes it has. Similarly we say bucket is a place where the element is being stored. Based on their hash code, after some computation with hash code it will give us the position, and based on that position the element will be placed on that position. And the initial size of that hash map is 16. It will be auto incrementing, like 75%, it will increase again. Okay, what do you mean by 75%? If the size is what 16 is size, so it will increase 8 times. So 75% is 12 of this, so it will increase 12 plus 16 plus 12, so the next size would be 28 in that case. If we have same index position for two elements, then the collision will happen. And to solve this collision, Java have provided the linked list, and after Java 8 we have the red black tree, which is more better to save the elements. Okay, now let's see the code for this. Workspace not available. Retry this. YouTube currently in use. Okay, retry. Okay, I think we have opened twice. Okay, okay, launch. Okay, okay, let's close this. Cancel. I have clicked too many times on this, so that's why this was happening. Okay, so collection framework is pretty much very easy and very important part. Collection framework defines what to use to process the data and to store the data, to manipulate the data. We use collection. In collection, this is collection, you see, this is collection, and we have collections also. Collections is a class, but collection is an interface. Collection is an interface, but similarly we have collections also. What we have? We have collections. Collections is a class, with S is a class which has methods like collections.sort, collections.reverse. Inbuilt methods we have, we can use them. Collections.unmodifiable list. There are numbers of methods here, we can use them. It's not opening yet, so let me start show you on compiler, online Java compiler. So here I'll create one hash map, right? So let's create one hash map. New hash map will, okay, hash map. And we'll give the data type here. In HashMap we have wrapper classes like integer for number and string for words, and I'll give it map equal to this. So we have hash map. Now we have to import this also. Import java dot util dot I'll do star. Okay, it comes from Java package, Java util package. Now I'll add map dot put roll number 1 and I'll give name JITND. Now let's give, I'll have 5 data. Let's do this 2. Now let's do 1 and do Rahul, and let's do 3 and I'll do null here. Let's do null, give MJ here, and I'll add one more null. After null, I'll add Locky. So first I'll do simple iteration, positive case we are saying here. So you see, I'm running it. It will not show anything because I have not printed anything. SYSO. System new hash map, capital M. Is it started? Yeah, it is. Here. What the heck? It will be so okay. Let's create one class CLA. And I'll use collections framework. Let's write here HashMap demo. Let's copy all this from here and paste it here. Close this. M is capital. What is happening? I think the system is okay. Okay, now let's try SYSO MAP map. I'm printing map. So you see here, I have 1 Jitendra, 2 Jitendra. So that means the key is different, value is duplicate, it is allowed. Now next thing, I'm doing this. Now I have duplicate key, right? I'll run it now. Now you see 1 is Rahul, but I have given it Jitendra first and the second is Jitendra. So what have it done here? It has updated the previous value. It will override the previous value to the new value. Okay, so that's about duplicate key. It cannot have duplicate key. If it has, it will have the updated recent value. It will have, it will forget the recent last one. Now let's do this. At number 3, it can store null. Okay, at number 4, I have done this null MJ. So it can do this also. It can have null key also. Now let's do this. I have 2 null. Now it is showing, no, it is not showing anything. It cannot have more than 1 null. Why? Because the key is same. Okay, so it is overriding the value. It is overriding the right. So this is about HashMap. Now let's see how can we iterate it. So map iteration is quite different. Iteration, so it will be iterated like for map.entry we have the suggestion, and what is the key integer, what is the value, same thing, this, and I'll give mp here, this for each only dot entry set. So to iterate over map we need entry set. This entry set will give us the values, the key value. Now I'll do so and I will have mp dot get key and plus mp dot get value. Okay, now let's print it. So now we have key value pairs. Okay, so this is how we iterate. Okay, so that is all in this video. Thank you guys.